Welcome back, everybody. This is Steve with another retro computer video for you. This is a DTK 8-bit 8088 10 megahertz motherboard. This thing was the screamer of its day, and it's really funny. The 8088 processor lasted a long time. You could buy brand new 8088 machines at the same time that you could buy 386 machines, and people were like, okay, sure, no big deal. Because until graphical user interfaces came out, there wasn't really the huge demand to get things moving faster and faster and faster and faster. You really didn't notice it much unless you were really like a super power user. So this is what I had, and this was pretty cool. We have 8-bit ISA slots. We have an 8088 processor. We have room, it's over there. We have room for an 8087 math coprocessor. It has regular BIOS. It is maxed out on system board RAM. That is a whopping 640K right there. And a whole bunch of other supporting logic. And this is a pretty sexy little beast of a machine. Let's get it over on the bench and take a look at it. Stick around. I'm not even sure where this is going, but it's going to go forward, so let's go forward with it. This is an untested motherboard I got off of eBay. You saw that I pulled it up during the unboxing, the mailbag video that gave you a kind of a sneak peek of what was coming up on the channel, and here it is. So this is a DTK, where is it? It's on here somewhere. Yeah, DTK PIM-TBIO-Z, and it's written right there on the board, and that's an amazing feat of naming skill that they've got going on right there. All of the RAM sockets are full. The BIOS has one in, one out. I'm not sure if it's missing or if it's not needed or if it's some extra thing like basic. I have a manual for this that I was able to scrounge off of the interwebs. A little DuckDuckGo search got it done. This is revision 9. It has a Siemens chip on here, 8088 IP, and it does not say whether it's a 8088-1, 2, 3, whatever. This is supposed to be a 10 megahertz turbo board, so we will get to figure out whether that is accurate or not. And it has a 30 megahertz crystal and a 14 megahertz crystal. Let's see. What else do we have? You saw the ATX to XT-AT style power connector adapter that I got, and then hanging off the back we have a XT to AT or PS2 style adapter, and I have my trusty Dell PS2 keyboard, which I believe was made by Logitech, and we have a Trident VGA card. This is an 8900C card. And it has a full complement of video RAM. That should be 1 megabyte of RAM. You've got your video feature connector, and this is technically a 16-bit card, but it is supposed to work in 8-bit only slots. I have tested this card in a 16-bit slot. It does work in a 16-bit slot, so we get to test this first together and see whether it works in an 8-bit only slot. So we will go ahead and connect that right away. And what I'm doing is I'm putting it in the slot that is farthest away from the power supply so that there is as little noise as possible. If I had a sound card, when I have a sound card, I will stick that over there. The power supply on an ATX style machine only goes together one way, so there's nothing to worry about there. On an XT style connector, it goes together by having the ground cables, the black wires, next to each other, and if you flip them around, which you can flip them around, you will destroy this thing. So these two wires floating off here should be the power wires, the power switch wires. I don't have a power switch with me, so we will do the fun thing and marry these together and make that work. So let's get this thing over to the workbench, the other workbench where I have all the monitor and stuff set up. Let's get the camera pointed at the screen. There is no signal because there is no signal. Nothing gets by these screens these days. What I have is my ATX power supply that I showed you. I've got the green and black wires jumpered, the jump start of the ATX power supply, so all I have to do is turn the power switch on, So what I'm going to do is turn the power switch on for the first time, and we're going to see what kind of magic this thing produces, which could even be some magic smoke. We'll find out. Alright, we got the keyboard LEDs lit up. The screen is gone. Okay, so that's only 1 meg of video memory, 512K. Keyboard error, that's not good. And then it flashes away into oblivion. Let's watch that again at normal speed, because I don't have any way to slow this down. Alright, VGA card works. There we go with 1 meg of VGA memory. Keyboard error. And it tries to do a RAM test, and it gets to 192K and fails. So, one of the things that I noticed when I bought this board, and that was perfectly okay, is that it had a bunch of numbers on the RAM chip. So let me show you that real quick. Oh, hang on, tripod's being stupid. There is a bunch of printed labels on the RAM chips. So, these RAM chips might be bad. Don't know yet. They also might be misconfigured in the BIOS switch settings. Okay, so this is actually a really interesting board in terms of memory layout. There are 4 banks of RAM. Count them, 4. 1, 2. It's actually 3 and 4 are here. So this is bank 0. Bank 0 is made up of 9 pieces of 41 256 RAM. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 256K of RAM. Bank 1 is made up of 9 pieces of 41 256. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That makes sense. So 256 plus 256 is 512 megs, 512K of RAM. If I said megs, I meant K. You guys know what I'm talking about. Bank 2 is where it gets a little weird, is made up of 2 pieces of 4464 in U63 and U59, and 1 piece of 4164 in U55. So I need to find U55, U59, and U63. So we have 55, 59, and 63. 55 is supposed to be 4164, and it is a 4864, so that's the wrong chip there. U59 and U63 are both supposed to be 4464s, and they are 4164s, so those 3 are all wrong. And then, what's the next one? Bank 3 is 2 pieces of 4464 in 72 and 67. That's a 4164, that's a 4164. And finally, a 4164 in 76. This is 76, and that is, in fact, a 4164. These 4 here are supposed to be 44s. These 2 are supposed to be 41s. These are all 4164 chips. And this one here is a 4864. And interestingly enough, these are larger packages. So we have 1, 2, 3, 4, 5, 6, 7, 8 versus 1, 2, 3, 4, 5, 6, 7, 8, 9. 9-pin 4164s, 8-pin 4164s. So this machine is supposed to be able to work in a couple of different configurations, and what we're going to do to make troubleshooting easier is we're going to go down to the absolute smallest configuration that it can handle, which is 1 bank of 41 256s, which I have 2 complete sets here to deal with, and nothing else populated. So I'm going to get, this one has the only one is populated, and then these 3. And what that is going to tell me is when I turn the machine on, I get a RAM count that goes up to 192K. This first bank is supposed to be 256. So if I still get to 192K and die, then I know that one of these chips is bad. And so I can swap this entire bank over and see if the number moves, at which point I will know that some of this is bad and some of this isn't bad. So let's get after that. And this is a handy-dandy chip lifter that I got from Dr. Dave's Diversions, so we will see how well that works. And it works very well so far. I'm liking it. And the goal is to not bend any pins and not break off any capacitors or anything like that. So what I'm going to do is I'm going to pull these chips out, and I'm going to sit them in the order in which I pull them over on the mat off screen. So let's speed through that. Okay, so the weirdness didn't change, but continuing down the troubleshooting path, the weirdness didn't change, meaning that we're still at 192K of memory instead of 256. I'm going to remove all of these. I'm going to take all of the ones that we took out from this row and put them in, and then we'll try it again. And these are going on this side of the desk, where the old ones that I took out were on that side of the desk. So that will be the next thing to do. Alright, so I've got those all in. The chips that were in this bank have moved to this bank. The chips that were in this bank are over on the side of the desk waiting for further evaluation. This would be much, much easier of a job to do if I actually had a RAM tester that tested these kind of chips, but hopefully when I get this board working, I will be able to use it to tell me what RAM chips are good or bad. So let me take this over, plug it in. If I see some magic, I will let you know, and if I don't, we will do some more troubleshooting. So what we got was reverse progress. We got the opposite of progress. We got congress. I put all of these chips in, and now I get no boot at all. So the next step, I think, would be to start messing with the chips that we took out and set on that side of the board and see if we can find what the bad chip was. But at this point, what I have is one board. I know the board overall works because I get video signals. They're a little flaky, but I get video signals. And I did get a RAM test up to 192K. So I know at least the first 192K are free and working from the other stack of memory that's off the screen here. What I will need to do is start doing some more troubleshooting. So while I have it here, I will check the solder joints on the back. They look clean and untouched, so I'm going to continue to leave them clean and untouched for now. It doesn't look like somebody's done some rework or somebody's already been hacking at it from that perspective. What it does look like is the seller tried to mess around with some RAM and figure out what combinations work, which would indicate why all these stickers are here and they were all out of order. So I'm going to start doing some RAM combinations and see what I can figure out, and I'll let you know what the results are when I have any to share. Okay, so this is super interesting. After doing a whole bunch of different combinations and permutations of RAM testing, those are big words, I know, they just mean I changed a lot of things. What I did was I tried it with just one bank of RAM in, which should be 256. I tried to move this bank of RAM to this bank of RAM. It also didn't get any better. I removed all of these chips here. That didn't get any better. So this motherboard's kind of weird. This is bank 0, this is bank 1, this is bank 2, this is bank 3. So 256 plus 256 is 512, plus, I'm not going to math on camera because that's hard, gets you up to your 640K, and 640K is all you'll ever need. Where the weirdness comes in is because these three slots up here, these three 8-bit ISA slots, act funky. Let me rearrange and I will show you what happens, but essentially what happens is the machine doesn't work unless you have the video card moved over because these three slots are funky. So let's regroup for that. Hang on. Okay, so I've now got you pointed at the screen. The motherboard is down below where it used to be in the last frame. I've removed the floppy disk controller and I've put the video card in the first slot. Let's turn it on. Click. And the screen changes over and you get 512K of RAM. Proceeds to boot. It gets to about 192K and it freaks out. And the screen really isn't dirty. I actually cleaned it. I don't know what's going on there. I'm good at building computers. I'm not good at cleaning screens. Turn it off. Turn it back on again. Let's see what we get this time. Nothing has changed. 1024K of memory. Last time it was 512. We're going to get up to 192K. We're going to freak out. Turn it off. Turn it on again. 512K of memory. Again, I mean, you can hear me turn the thing off and on again. I'm not really playing games here with you guys. I mean, I can. We'll play games later. Okay, promise. We'll play games later. And nothing. So I moved it over to slot 2, I moved it over to slot 3. I guess these are actually counted in the wrong direction. This motherboard has 1, 2, 3, 4, 5, 6, 7, 8 slots. So I moved it from slot 8 to 7, from 7 to 6, from 6 to 5. Slot 5 is where it starts to get interesting. Let's put it over into slot 5. And I think that it was purely accidental when this happened, but I put it into slot 5, which was the same point when I just put the RAM in, and I thought to myself, see, 1 meg of memory again. Steve, this thing doesn't have anything to boot off of. That's probably why it's freaking out. It's probably just getting through the last bit of memory testing just fine. Okay, so like I said before, the floppy disk controller is missing, so there is no floppy disk controller. But we now have 640K of RAM, and we have 1 meg of video RAM like we're supposed to. So boot record not found, strike any key for reboot. Great, let's turn it off. Let's put a floppy disk controller in. The floppy disk controller, let's see if we can get some settings on there, some visibility on there, has its own ROM chip right here, and this switch is for ROM enable. Great. Let's put the floppy disk controller in. That's in. We have our Gotek floppy drive. We'll put that onto the DOS 622 image. 1 meg of video RAM. Let's test system RAM. Hey, all the system RAM's there. This is the BIOS from the floppy controller card, and it is currently reading the floppy drive, and we're working at massively fast floppy disk drive speeds. I'll speed this up for you. Yay! It boots up. Alright, awesome. So before we get too far, there was another jumper on the motherboard that disables the keyboard. This is an old-time thing that old computer cases used to have that were... they had a key lock on them that you could disable the keyboard. So for some reason you have to complete the circuit to enable the keyboard, and I would have thought you would unlock it, which would then open the circuit, and then the keyboard would be complete. So now, the floppy disk controller, which you've seen work, here is the, if I get that in the screen, here is the XT IDE controller, and I have a compact flash card attached to it. We're going to put that into the same slot that the floppy controller was in, and we're going to boot off of the compact flash card. Alright, that's in the slot. Let's turn it back on. See what we get. 1024K of video memory. Run through RAM test. 640K of RAM. There's no floppy disk. I showed you that there's no floppy disk. It's booting off the hard disk. Yay! It boots off the hard disk. Okay, so now we can get it to boot off the floppy or off of the hard disk. So here's where it gets to be a little more interesting. The BIOS on the floppy card only does floppy disk support. The BIOS on the compact flash card XT IDE adapter does both floppy and IDE adapter type stuff. So I have flipped the switch down for the disabling the floppy BIOS. I'm going to stick the card back in. Let's turn it back on. So now I have the video card, 1 meg of memory. I have 640K on the system board. That all tests out fine. There is the booting off of the C drive. Great. Now I do dir A:, and the drive light lights up on the A drive, and we get nothing. We get an ARF, abort, retry, fail. So we abort. Great. This is where I'm at. This is the same spot that I arrived at on the compact portable. One or the other works, but not both. And I have no idea where to go from here. So, what I'm going to do is I'm going to take the floppy disk drive controller out, and we're going to play with the machine and see what we can get. So first thing I want to do is make a nice friendly prompt after I get a nice friendly chair. Alright, so prompt, spelling correctly. There we go. Now we've got a nice friendly prompt. Let's see what's on this hard disk that I put on here. Okay, so we've got check it. Let's run check it. Check it's going to tell us a couple of interesting things, mostly that everything's fine. We're not working remote. BIOS manufacturer is standard. Determine system components complete. Look for RAM. We've got some. No math coprocessor. No mouse. That is all correct. Configuration. We're running DOS 3.3. That is true. This is an 8088 XT machine. We've got 640K of memory. We have a VGA card, which we do. Video RAM size is not properly detected, but that's normal. Hard drive size is minus 301 megabytes. That's wrong. But I think that's a bug in Check It, not a bug in anything else. Floppy drives, A present, B present. No clock, no calendar. The serial port is there. There's no mouse because I haven't run a mouse driver. No joystick because there's no game port. Great. Memory map. Alright, so we have video RAM, VGA video ROM, Trinet Microsystems. That is true. Here it says that there is nothing installed, and there actually is something installed. The XT IDE BIOS is installed at D1000, and from C800 to F400 it says there is nothing, and that is not true, and we're actually booted off of it. So I think that's another Check It bug. And then system ROM, and it says the ROM BIOS is standard and the BIOS date is 01/01/84. That is correct. So let's do some benchmarks. Main system, let's see how fast this puppy is. 8088 at 10 megahertz, that is awesome. And it is checking the math speed, and we do not have a math coprocessor, so there. Alright, so 717 dry stones, 13.9 wet stones. So this motherboard has a turbo switch, and you push the turbo switch to slow it down. So I have now pushed the turbo switch. Let's rerun that again. 337 dry stones for CPU speed at 4.77 megahertz. And 6.5K wet stones. So roughly half the speed by putting the little jumper, where is it? There it is. Putting the little jumper over the switch, which closes the switch. It's the same as pressing the switch on the front of the case, that magical case that you saw that I did not have. So we put the jumper back on, and there you have it. Let's see what else we can get ourselves into. What other kind of trouble do we have? Let's see, we have Planet X3. Let's see how Planet X3 looks on this screen. PX3. And I have no sound at all, so we'll pick PC speaker. Oh, look at that. Told you we'd play some games. And this is a pretty neat little game made by the 8-bit guy, and it is a real-time strategy game where you get to go and build up your base and build up your attack forces and attack your enemy. This is a fantastic game, and it's actually fairly affordable. You can play it on any 8088 PC or anything newer, but it's actually designed to be playable on an 8088 PC, and it does very well. It's got a fantastic soundtrack, so we just need to kill the enemy or let them kill us. And maybe we'll play that a little bit later in a different video. Exit to DOS. Have a nice DOS. Why, thank you, David. And there's a whole lot of stuff on there, but we can go into GW Basic, and we can do our usual print. There it is. Hey, that fits into 80 columns pretty nicely, I think. Can we break out of it? Hey, we can break out of it. I actually have a break key on this keyboard. This is amazing stuff here. Alright, so we got it all working. We had a little bit of fun trying to get the RAM sorted out. Turns out it wasn't a RAM problem at all. That was kind of weird. I am going to have to take a look at those slots and see what's going on. I don't know what it is. Like I mentioned on desk over there, the slots don't appear to have been reworked at all. So I'm going to try and see what I can do to make some improvements to those guys, but I really don't need them yet. You know how that works. What could I put in? What 8 ISA cards could I put in? Obviously I need a sound card. Absolute need. I need to put a sound card in this. I need a video card. I need a second video card because we have to use dual displays. I need some way to access data, so a hard disk card. I need a floppy disk card, and I need some ports, and possibly a network card. So I'm counting like 6 or 7 cards there. If you can think of any cards that I haven't thought of, maybe a network card, let me know. be interesting to try and like SSH or Telnet into this thing. That would be pretty cool. Where do we go from here? What can we do to get the floppy controller and the hard disk controller to work in harmony? Because this is two different machines that I have the same problem in, and the problem doesn't make any sense to me. So leave a comment below. Let me know what you think about filling up those I/O slots, fixing those I/O slots, or how to get the hard disk controller and the floppy disk controller to play nicely with each other. We got a lot more exploring to do with this thing. I want to get it inside of a case sometime in the future. I also want to test out some other 8088 type parts that I have on other boards. I've got a video card that I'm in the process of building that I need to finish fixing up. So you'll see this quite a bit more in the future. And I appreciate if you would hit the subscribe button down below and ring that bell if you want to see the rest of the videos in this series or in any of the other series that I'm working on currently. So thank you for watching. Thanks for being awesome.